Well, here we are, guys. This is my power supply for the power Flip Flop. And here's my little kludged up mess over here. Now this transformer, all this is, it can be a 6 or 12 volt or 24 volt center tap transformer. And this one came from radio crap. It's just a 3 amp 12 volt center tap $5 transformer. That's the biggest that they had that would handle the amount of current that I perceived that we was going to use. What I've got set up here on our little test is this meter is going to show the input current, and this meter is showing the output voltage, and then we will check the frequency. And then I'm going to show you the beautiful little square waves up on the oscilloscope that are coming out of our transformer. Alright, let's turn it on. As I said, there's only 9.6 volts. Our light is lit. We're drawing 1.7 amps, and we're putting out 188 volts. So that's pretty amazing. Now, you'll bear with me. I'll swing up here to the oscilloscope and look at this beautiful little square wave up here. That is a beautiful wave. We got a little bit of ringing on the forward edge, on the trailing edge, but we can tune all that out. And I think that's what we're looking for is a square wave. Now, one of the next things that I want to show, and I don't have the test set up. So I also wanted to show you that the neon tube or the fluorescent tube back there can also be used as a high voltage rectifier, much like we used to use the old NE2 gas cell. Anyhow, there was a little question about where to get the transformers and stuff. I went to Radio Crap. This is the best I could find. I wish we still had Allied Electronics on the corner or something like that, where we actually had electronic parts that we could get without ordering over the internet. So there we go. Let me oh yeah, frequency. We'll put the meter over here on the frequency band. We'll find our probe and check it out. We are running at 2.8 kilohertz. They're about there, 2.8, 2.9. I don't think that the power supply really needs to be that precision in the frequency that it runs, as long as that you're somewhere close to the resonant frequency of the transformer, or multiple resonant frequency. You will find a place where that transformer will produce as much as it can, and that is the resonant point that you want to set your values of C for. I changed this circuit. I have 10 microfarad caps in here for the timing caps, and I changed the base bias resistors to 200 ohms instead of 180 ohms, and the collector resistors are just 10 ohm. This happens to be 10 watt wire wound, is all I could find. But the transistors and the dual diodes all came out of an ATX power supply. By the way, when you build one of these, check your transistor and make sure what the maximum collector current that transistor will allow. It just happens that these transistors are a 10 amp transistor, and so I modified my resistance of the collector resistors to reflect that. I hope this is not too much for you to understand, or at least the ones that are working with me, I guess they're working on the same level. So Next, we're going to show the effects of using a fluorescent tube as a rectifier, which is kind of interesting. It's a high frequency rectifier. And then we will get into putting a standard bridge in and see the differences on that. Alright, maybe this has clarified some of what I'm doing. I'm not really up to the point of putting it to my cell yet. I'm kind of redesigning the cell in my head, and I want to get into some exotic metals. I want to get into some beryllium, and I want to go into the nickel cobalt. I want to go into Monel, Inconel, all of the stainless steel series from the 300 to the 500 series, and building the cell with different material plates in it. I think that we might be able to gain some advantage that way. Remember, we're not building a battery, but we are building something that's quite similar to it, a capacitive reactor. Well, anyhow, I hope this brings you up to date. It's a cool little experiment. It doesn't take much to do it. These are 9.6 volt, 1000 milliamp hour battery packs. It was laying around from my previous experiment, and it seems to be working. It won't run long at that frequency. I mean, at that current level. It'll run maybe an hour. There it is. There we go again. See, the frequency jumps around 2.4 kilohertz, and the current is fairly constant here at 9.6 volts, and we are still putting out 190 volts. Alright, thanks for watching. I hope this hadn't been too boring. It's a lot of what we can do with what we find laying around. I'll start showing how to wind some of these transformers, as I have taken this circuit all the way up to about 2 kilowatts, and they work quite well. They're very easy to assemble. So there we go.